Okay, yes, so that's right. I'm here. So first of all, Andrew Martin, my colleague, sends his apologies. He was due to speak today, but got deadlined at work on another project, so I've stepped in to do it. But we're both co-founders of of Control Plane. So we're pretty much the same person anyway. As a joke, we both like to make. I always get called his name. He always gets called my name. We worked together for years. So yes, my name's Luke Bond. I'm co-founder of Control Plane, as I said. We're a Kubernetes security consultancy based here in London. I'm also one of the, that's really weird having my face so massive behind me. I didn't think of that when I was making the slide. I'm also one of the coordinators of Meetup Istio London. And my background is more from like the development side, I guess. So who here would say they're more like developers? Yeah, Istio seems to really interest developers, I find. More operations. I appreciate everyone's going to be bits and bits. Equals 50-50? Enough for both. What about anyone here from, sorry? 60-40. 60-40? 40-60. What about anyone, is anyone here from like a security background? Either like either in a security role or security management or something like that? Cool. I say that because I think that's particularly, for me, that's one of the most, well, as a developer, probably the most exciting thing about Istio and Service Mesh is probably more continuous deployment stuff for me personally. But I think one of the most important things about it is probably the security aspect of it. So we're going to talk about that. So it's essentially an intro to Istio talk with a security focus and continuous delivery focus, I guess, is probably how I could summarize it best. We're obviously all here interested in continuous delivery, I presume. Anyone not? No, cool, with the right audience. So it's going to be about that and security on top of Istio, essentially. So I'll be talking about what is the service mesh. Timo gave. Is anyone here in the previous talk just now? I think quite a lot of people. So that's really good. He gave me a bit of a head start on the Istio stuff, but it's a nice little introduction there. I apologize, my slides aren't quite as pretty as his were. These were really cool. I guess using a Mac, right? Cool. So then we're going to talk a bit about how Istio works and how we can move to adopt to it. I think, well, as I see it, one of the things I've done a lot in my career is doing consulting for. I mean, now it's more Kubernetes security stuff, of course, but in the background, a lot of development teams and how to make sure that they deliver effectively, structuring them into feature teams and moving to microservices and breaking down monoliths, all this kind of stuff, right? So these kind of problems are important to me, I guess. So for me, if you sort of boil down the business problem of what a lot of enterprise companies are facing, I think it comes down to this sort of thing. So basically, they want to make sure that they can get features in the hands of their customers as quickly as possible. And I think a lot of what they're trying to do around digital transformation, all of that boils down to that. Obviously, it's not quite that simple, but I think that's a big part of it. Consultancies and organizations that are doing digital transformations, often it's about that kind of thing, at least when it comes to impacting developer release teams and things like that. And there's a sort of looming specter, depending what industry you're in, that some more nimble competitor will come and disrupt you. So I kind of want to frame the problem in this way as a context of what I think Service Mesh and Istio can do for you, and then I'll tie it all in with continuous delivery and security. You might, I just don't know if this is going to work as a tagline, but you might say that it's maybe digital transformation is something like a diet for enterprise where the food being restricted is their own ossified culture. It's kind of something I'm toying with. No, maybe. Essentially, they're like stuck in their ways, and they're so big that it's hard for them to change. And it's a culture that ultimately needs to change much more than being about technology. But I big believe that Service Mesh and Istio is part of that. So this is kind of common sense, right? It's 2019 now. We all sort of know, or at least we've been told enough in conferences and things like that, that the way forward is microservices and continuous delivery. I'd like to believe that anyone who practices that sufficiently really comes to believe that as well. I believe that myself. But just saying that is not really enough, right? A enterprise organization who's struggling with this problem statement on the previous slide, you can be like, move to microservices. It's like, well, what am I going to do with my Windows monoliths? Like, they're making all of their money, and I can't just simply, digital transformation that away in a few weeks, right? In a sense, this is about microservice principles and moving your organization to change the way you build applications along the lines of microservice principles, right? But enterprise companies have big, what you might call legacy or maybe heritage applications, the ones that are their bread and butter that are making them money, right? An enterprise is not weighed down by its greenfield projects or the design choices it makes on its greenfield projects. It's these big legacy applications that they have. Digital transformation, when it comes to like when you're applying it to an organization like that, at least, digital transformation means a lot of things across the whole company, right? But I'm talking here about how it applies to development teams. It generally means using, say, a strangler pattern around a big monolith legacy application, breaking it down to microservices bit by bit, and eventually replacing it. And along the way, building out feature teams that can be more agile and all this sort of lovely stuff we've been hearing about in recent years. However, the enterprises have other pressures to move to cloud as well. If they necessarily sit and wait until all these applications have gone away, and then move to the cloud. Doing all this sort of stuff at once is difficult. Doing it only for your greenfield applications, but keeping your legacy ones aside is also creating divisions within your organization. I'm just trying to paint here that there are a number of problems going on here at once. There are a number of competing forces that are pushing enterprises in different directions. And it's more about what they're weighed down with is more about their legacy applications than their new greenfield ones, right? So that move to the cloud might be more about, they might want to, say, lift and shift what they already have because they need to move now, because they need to do so for reducing infrastructure costs or being able to scale out into different markets or reduce their operational complexity and things like this, maybe many other reasons. Anyway, we're here to talk about continuous delivery. Just want to say it's not necessarily as simple as move to microservices. Okay, so, and also running things on premise has its advantages, or at least its apparent advantages. There are certainly many compliance cases where enterprises need to run on premise, or at least feel they need to, because they've not yet got the controls in place in order to run somewhere else, and there may be very much immovable barriers to them moving to the cloud and staying on-prem because of laws about where the data can live and things like this, right? So not everyone can move to the cloud, or if they do, they have been running on the cloud, it has probably had certain advantages for them that have made some aspects of their life easier. So with physically segregated networks from the public internet, it might lead to some habits in application development and network design that are built on the assumption that no one can get in, maybe, perimeter-based networking. Physical controls around access to machines and access to the building and all this sort of stuff will also influence the design of applications. Having dedicated hardware, not having to co-tenant with other organizations or other customers, these kind of things. I just kind of, the reason I'm sort of dwelling on this is because when I was, like working as a developer and not yet done a lot of enterprise stuff, I would hear about these problems and I'm like, it's not that difficult, right? Just you code some sample app and it's going to be that easy, right? But the reality of enterprise problems is much more serious than that. It's much bigger than that, and it comes around compliance and policy and all that sort of stuff within an organization. So the design of these legacy applications is not necessarily cloud native, to summarize. Right? So if we go back to that problem statement a few slides back, what I'm kind of trying to summarize here is that enterprises need to move faster because of nimble competitors and that sort of thing. They need to move to the cloud. They have various pressures for that. It may be as simple as a new CTO has come in and has decreed that it needs to be done and that it needs to go, it needs to happen. That is something I see often as well, no doubt for very good reason, but they have competing pressures for these things. Their legacy software can't be easily discarded. It may run on something that's inconvenient to move to the cloud or to move to a cloud-native orchestrator or something like that, but it needs to happen. And there can be security risks around moving applications to the cloud. That might be because of the way the application works, it makes assumptions about being in a perimeter-based network where no one can get in. It doesn't necessarily encrypt traffic, or perhaps it's built on the assumption that you can only access it through the company intranet and all that sort of stuff. There are reasons why just moving it into the cloud might expose a whole bunch of sensitive information. So having sort of painted all this picture, what we really need is an upgrade path to the cloud and to cloud native ultimately. That doesn't necessarily depend on a complete digital transformation having finished and worked. Now it's all beautiful greenfield, or at least as of the date we started designing it. There are realities when companies may need to move there sooner. And enterprises sort of need this yesterday, and it needs to work with what they've got today. So my kind of hypothesis, what I'm proposing, is that Service Mesh and Istio are tools that can really help on this upgrade path to ultimately to continuous delivery and to cloud native. Don't mistake that for me saying that they're some sort of like silver bullet. They come with their complexities, absolutely. Timo talked about that in the previous talk, about the number of components of Istio. It's a learning curve. Enterprise companies aren't necessarily there at cloud native yet. Anyway, it's not a silver bullet, but I do believe that that Istio is essentially a useful component to take us there. So let's step back a moment and look at what a service mesh is. I would sort of call it application-aware networking infrastructure. What does that really mean? It's a place. If you imagine that the fiber of the network across which applications are speaking, you're able to configure policy on it, and you're able to integrate. You're able to configure things like application network policy, what can talk to what, request quotas. You're able to do circuit breakers, all the kind of things that you may have come across with something like Netflix Hystrix. Does anyone know about Netflix Hystrix? Yeah, I think it's quite widely used. So a lot of these kind of features, but if you imagine it built into the fabric of the network over which the applications communicate, then this, for me, is what a service mesh is. So we get all these features like the Hystrix type 1s, intelligent routing and load balancing, cryptographic workload identity. So a workload that's claiming to be microservice A, we can actually verify that it is in some way. Network policy enforcement, I'll talk about that in a moment. Basically, what can talk to what and setting some policy around that. As well as in-depth telemetry and reporting. As you might imagine, this infrastructure network layer that has all these features built into it is going to not know a lot about your application traffic, and therefore will be able to provide a lot of information around telemetry and reporting. None of these things in and of themselves are like new concepts. We have them already in Hystrix. We have them independently through, I don't know, I'm not a networking person. For all I know, in some hardware networking components, you might have some of these things, presumably. So they might sound like things that already exist on, when I say layers, I mean the OSI model networking layers. That probably exist around here, right? Things like network policy, even in Kubernetes. We're talking about this kind of part of the OSI model. But in fact, in Service Mesh, or at least in Istio, which is, I would say, is an instance of Service Mesh, it's a particular Service Mesh, this actually reaches up to layer 7. Layer 7 being the application layer. So protocols like HTTP, for example, belong on layer 7. So it's not simply network. Layer 2, 3, 4 stuff, it's more to it than that, even though these things in themselves aren't necessarily new concepts. So if that is what Service Mesh is, what is Istio? I would say that Istio is the Service Mesh. It's one that came out of Google and IBM. It was released. Anyone know what year it was released? I remember where I was, but I don't remember which year it was. I was on a bus in Australia. I read about it. It was either 2015, 2016, was it? I was there for Container Camp. But yeah, released by Google. It's an internal project it's a project that started within there in collaboration with IBM. IBM had a similar project that they were developing internally. They got together, presumably bumped into each other at a conference. I'm not sure how it happened exactly. And realized that they were working towards the same thing, and they're like, let's start this together. Let's combine what we're working on here. Design-wise, Istio is made up of a control plane and a data plane, not to be confused with this control plane. As Timo was saying before, Kubernetes has a control plane itself. The concept of control plane you can think of as like the management part of a cluster, the part that is storing the global state and is taking action based on desired configuration and that sort of thing. All these components live in the control plane, and then in Istio we have the data plane, which is essentially where the actual application traffic flows. So in the control plane for Istio, so if I said, as I said in the previous slide, that a service mesh is an application-aware networking infrastructure that can be configured along the lines of all these things that we might be familiar with from something like Hystrix, then Istio is a service mesh where the control plane contains the components that allow you to configure that. So it has APIs for configuring the central policy, configuring the policy centrally. It has its own certificate authority, which of course can be unplugged, you plug something else in. This is where the components live for the service identity and credential management for establishing the trust for workloads and between components. Also is a component called the galley, which is interfacing with the underlying orchestrator. So in the case of Istio, that's Kubernetes. And there's also a component whose job it is to push out all that centrally managed policy to the mesh so that it remains up to date with the config as it's being configured in the control plane. So the data plane is the part where you essentially, it's where the traffic between applications is actually running. And that is effectively a fleet of Envoy sidecars. I'll show this in the next slide, we'll have a picture of it. But every one of your pods, if you're not familiar with Kubernetes too much, you can think of it as more or less like a container. It's not quite that simple, but every one of your applications that runs in a container has a kind of an Envoy proxy sitting next to it, just like you might put an application behind an Nginx reverse proxy to do TLS termination or something like that. You can imagine something like that, but using Envoy instead. And Envoy is being constantly reconfigured with all of that central policy from the control plane. In terms of contrasting service mesh and Istio, because I think, if you were being introduced to these concepts at the same time, you might be like, what's what? Istio is an actual project. So you might say that this fleet of Envoy sidecars, that is basically the network ingress and egress for all of the applications, and it's the point where policy is enforced. It's kind of like the logical fabric of the network for all the components. You could say you would say that is a service mesh, whereas Istio is a project that gives you all these components as well. Okay, so let's look at this a bit more visually, considerably more visually. So this is where we have our application components, say service A, service B, all of our microservices. Each of them is is living together in a pod with also an Envoy running in the same pod. And all of the traffic, so if service A wants to talk to service B, then it goes out via the proxy and in via the proxy and into service A. That means the proxy becomes an integration point for configuring things like, these services mainly talk HTTP. The application developer may never need to consider things like TLS, and you can put all of that into the Envoy proxy. So Envoy proxy can effectively become an adapter for gRPC communication between your components, but your application only speaks HTTP. As not necessarily the thing that's most exciting about Istio, but just to show you that the proxy is that intersection point for all the traffic. And it's giving us mutual TLS, which is bootstrapped by a component within the control plane called the Citadel. It is a certificate authority. It is a key part of establishing the trust for the workload identity. So basically, a workload that starts up, it is given an identity by a Citadel, and it's through the mutual TLS exchange that establishes trust between two points in the connection, is when you can say, okay, this service is actually cryptographically demonstrating that it has the credentials to demonstrate that it is who it says it is. So with that, you can. I'll go into this in a minute when it comes to security, but this gives you some confidence of traffic within your cluster not being sort of spoofed or being misrepresented as something from as a genuine service when in fact it's not. The pilot component, so yes, Citadel, certificate authority, and establishing the workload identity. The pilot component is the place where that centrally configures policy. So you speak to the control plane via the API, and you say, I want to set this network policy on the cluster. I want to set this various configuration. It's the pilot's job to send that config out to all of the Envoy proxies within the cluster. So you have centrally configured policy being distributed out via the pilot. The mixer is where the proxy needs to look up some policy. Doesn't need to do this for necessarily all requests, but there might be some policy such as rate limiting. If you only got the number of requests that have been not rate limiting, quotas. Let's say you're only allowed to, A is only allowed to make certain number of requests a minute to a second or so to some other component. The counter will be stored centrally in the mixer, and that will then be on the data path, not necessarily something that needs to be on the data path for all types of requests. If you've been following news of Istio recently, you may have heard that they're moving away from this model. The mixer is going to go away. There's not a lot of detail that I've read on exactly what that means, but for me, one of the nice things of that is that hopefully that will mean that there isn't a request on the data path to go and check policy. So it will certainly help with latency for that particular feature anyway. Okay, yeah, and also configured by the control plane API. Okay, so that's what Istio is. Why do we want to use it? This is from the Istio docs. This is basically outlining the kind of features that it supports, but in a little more technical detail, I suppose. You have here the information I was saying from the previous slide, where it can be an adapter between gRPC and other kinds of connections. We're able to get all that traffic control rules that we configuration that we get with things like Hystrix. That allows us to do stuff like rate limiting, circuit breaking, dynamic routing to say maybe 5% of traffic or that matches some particular cookie. We need to go to this instance of the service. The rest can go over here. All this sort of stuff allows us to do all that. And also the tracing that you get from the knowledge of the service mesh being central to your networking of all your applications. Obviously, you're going to get metrics and tracing. And again, the workload identity stuff. Now, it says here all without changing your application. So there's a little asterisk there because you do need to forward on some particular headers. You need to make sure that the application does that because it's by those headers that some of this information is tracked. But for me, the reason to choose Istio as a service mesh over, say, something like Hystrix, I haven't worked with it. I'm not trying to take anything away from it, but just in terms of the way both projects go about trying to give you that feature set. Hystrix is a code library that you will bring into your application, whether it be a JVM application of some kind. You're bringing in like a jar file, right? It's like a code library that you use to wrap your network requests, and these features are implemented in that code library. So you do need to change your application to use it, and your application needs to be built against the version of the API that supports your language and all that kind of thing. Obviously, you're not maintaining the Hystrix project yourself, but you'd want there to be a version that supports the languages that you're using, the versions of the language that you're using. You might have a heterogeneous application that has some Python, some Node, some Java. I don't know. You would need to ensure that that library is available, and you're coordinating updates of the versions of it between your applications that speak it, all that sort of thing, right? Whereas with Istio, because it's implemented in the service mesh directly by centrally managed configuration, pushed out by the pilot to all the Envoy proxies around the cluster, your application doesn't actually need to know at all that it's running on Istio. Does that mean that any application ever will be able to run on it without any problem? Not necessarily. You do need to be able to forward on a header, and you would have to ensure that Envoy supports the kinds of connectivity that your application uses. But by and large, certainly for web apps and most kind of applications that I've encountered, will certainly run it without the application having to know about it. The way I kind of imagine it coming about, it's not something I have confirmed from someone from Google because they wouldn't say, basically. But the advent of just like Kubernetes has a predecessor within the organization called Borg, and Kubernetes represents the open source rewrite of that takes the lessons learned from that project rather than a rebuild of exactly the same thing. Istio also has a predecessor within Google, and it came about not long after the time where, do you remember that instance where the US government spying agency were grabbing information out of Google's infrastructure? And there was this slide where they showed how they were doing it, and there's a little diagram saying traffic's encrypted getting into Google's network, but once it's inside, it's all HTTP, and there's a little smiley face on it. Does anyone remember this? It's probably about 5 years ago, something like that. There was a thing in Google where over a few days they needed to just rapidly put HTTPS on everything, TLS on everything. I reckon that's the advent of the predecessor to Istio, where they're like, okay, we can't go around changing all these applications. We need to do it in the network. And as a result, hey, look, we get telemetry and dynamic configuration of routes and all this kind of great stuff off the back of it. So yeah, it's pretty cool. Like I said, I can't confirm it, but it at least fits in terms of what it gives you, Okay, so Istio and continuous delivery. Given the sort of the complexity of root rules we can configure and policy that we can configure for our application with Istio, as you might imagine, you can use those features for things other than just routing requests for users and things like that, and also not just circuit breaking and quotas and that sort of thing. We can also use those for different kinds of deployments. You can set rules to say, based on these particular headers, these traffic goes, 1% of the traffic goes to this version of the service, the rest goes to that version. What does that sound like? Canary releases, right? So you have the primitives within Istio to be able to configure your traffic, to be able to do things like blue-green, and be able to do things like canary releases. My colleague Andy spent some time wrapping that in marvelous Bash, as he's wont to do, to build something like an Istio canary release tool. But Flagger is a very mature project. Well, mature project that works with Istio. It is more mature than one you might build yourself. It is really cool. So Flagger from Weaveworks, Stefan Prodan, a very prolific developer in cloud native space. He's built a tool called Flagger so that you can express with declarative configuration the kind of rollouts you want to do to be able to do canary releases and blue-green deployments and all that sort of thing, and submit that to an operator within the Kubernetes cluster, and it will manage those rollouts and reconfigure Istio's traffic rules over time according to the configuration that you want. Really cool. So Flagger, the progressive delivery Kubernetes operator, as it's called. That's the link to the the link to the GitHub repository. So conceptually, how it works. You have Flagger that's looking at what's running in the cluster and things from Prometheus based on health checks and things like that. So it knows how a canary is going, for example. And then it's able to deploy a version of the canary and then reconfigure Istio to say, give it 1% of the traffic, monitor the health, give it 5% of the traffic, monitor the health, that kind of thing, and then do rollbacks. With Kubernetes itself, you can do something like a canary. If you had, say, 100 instances of an application of a microservice running, and you deployed one more, you've kind of got something like 1% traffic control, but it's only as fine-grained as the number of services you've got. I've heard people say that a rolling deployment in Kubernetes is a canary when they're talking about a five replicas of a service, when that's jumping like 20-25% traffic change in one go. For me, it's not as fine-grained, not sufficiently fine-grained for a canary. But Istio allows you to control all those sort of things. Okay, so Istio and continuous delivery. You can control your traffic. I recommend Flagger. Istio and security has some it has some important implications for security. So just like I said with that, well, let's say fictitious story of the advent of Istio within Google, I don't really know that for sure, but it does have security implications, positive security implications. So if a workload does get compromised, like Istio aside, just thinking about defense in depth, if a workload does get compromised, what you want to do, you want to make sure that the blast radius is reduced, that if someone does compromise it, they can't do too much, right? Obviously, we want to prevent the compromise, of course, but once they're in there, we want to make sure that if they've compromised the front-end API, they can't necessarily, so if they've compromised the server that's serving the web application, they can't necessarily talk to the database, right? This is just network policy, yeah? If someone does get onto the database node somehow, they can't just exfiltrate data across the internet to somewhere. Again, this is a network policy. But it's network policy that's being done. I only had so many glyphs available to me in Google Draw. This is supposed to be like a certificate. It's to represent the trusted workload identity. So so you have this not just at sort of layer 3. You have this at effectively layer 7 using HTTP headers that is passing around the cryptographic identity that demonstrates that a workload is who it says it is. So so this goes back to what I was saying earlier with the OSI model, where you these concepts already exist, and you probably will have something already in your cluster that's implementing network policy, such as Kubernetes network policy, operating at layer 3. Or is it layer 4? Anyway, in your network infrastructure. And your operations and IT infrastructure teams will probably have something around firewalls in place as well. You have this on multiple levels, and you want this on multiple levels for defense in depth. This gives you the ability to express network policy with the backing of cryptographic identity, and you're expressing it in terms of application workloads, not simply ports and IP addresses. You're doing it. You're saying you'd be able to express it more richly at the application level. So it's kind of like we're talking about it here in language that a product owner will understand. It doesn't necessarily need to be about IP and ports, but about what things can do at a level at which a CIO will understand, where they're talking. They care about the protecting of informational assets within an organization. You want this at multiple levels, and you want it with the cryptographic identity. Cool. And also you have, if you think about what you've got in terms of your whole, no, I'll come back to that in a moment. It also gives you, yeah, let's do it here. So if you look at, this is a diagram I've brought from another presentation about secure delivery to Kubernetes in general. In terms of the bit that Istio is giving you here, it's at runtime. Istio is not protecting you for your supply chain security. It's not protecting you for where you're building your images or where you're deploying them initially. It's here at runtime enforcing that network policy and traffic policy and all that kind of thing with the cryptographic identity. So it forms the final mile of your security story, I would say, up until intrusion detection, I guess. You've got your supply chain security at build time, where you're going to want to make sure that you're assigning your commits. They're committed by who they claim to be committed by. At build time, you're recording information about the tools that are building it, where it's being built, the provenance of the components that you're bringing into your organization, and then you're scanning them for vulnerabilities with some sort of scanner. You're testing it. You're recording evidence that all this stuff has happened in some way. You're blocking your deployments that don't comply to this policy. This is your story up until deployment time, but then at runtime, you've got Istio enforcing this. This policy. So this also gives you protection against, is that on this slide or this one? No. This also gives you protection against malicious internal actors. So someone who is able to, with malicious intent for the value that they could possibly get out of it, they want to commit code in your organization, have it go through the pipeline unnoticed, and to run in your having some compromised code effectively running in your application. I don't know how many of us can be sure that that's not happening in their application. Obviously, like what are we all running that is necessarily worth all that and risking your job? Some people will be working on those things in government work and finance and that sort of thing. Once that code is running in your cluster, what can it talk to? What can it do? What policy is there in place? If they get to the host, what can they do? Can they launch other workloads? Can they grab a service token, deploy other things? Istio is there in place at runtime to help to make sure that you have that runtime security about inter-service communication. So what might a pipeline look like that embodies all these things? Istio, right here at the end, is the one that's giving you the end of that story. But you want to make sure your commits are signed. If you didn't know, the Merkle tree implementation within Git is there to ensure integrity, not identity. It's not an authentication mechanism. You can impersonate commits. You want to make sure that when you're looking at the audit trail after an incident, you want to make sure that that you have that certainty that your commits can't be at least can be traced back to who did them, right? Secure supply chain. This is off topic here, but you want to make sure you know the provenance of your components, how they were assembled into the build chain, and that they weren't modified down the line. Scan for vulnerabilities. I'm sure we're already doing that. Your organization is going to have a bunch of policy around, like say a release manager to sign off an application. It's going to be like, I want to see the tests, I want to see the scan results, I want to see all these things. You can record signed metadata for these things and look them up at the end of the day with an Kubernetes admission controller. You can't deploy anything to Kubernetes that doesn't go through the API. The API admission controllers is an opportunity for you to do some checks, write a little webhook, do some checks, and return a 200 to let it in or not. There's no other way for it to get in there, short of modifying etcd directly, perhaps. Static analysis on your Kubernetes YAML, have network policy, and ensure that those routes that should be routable are, and the ones that shouldn't are not. You can use a tool like netassert there. On static analysis of YAML, kubesec is a tool that will take your Kubernetes YAML and give you a score, much like a kubebench type thing, but on your Kubernetes YAML, and say, you're missing pod security policies, you're missing security context, you're running this as root, and all that sort of stuff. Decouple your build from deployment with GitOps. In the previous slide, Timo was talking about that sort of indirectly, but if your CI system needs to deploy into your server, into your cluster from the outside, then it needs to have the keys to your kingdom effectively. Obviously, you can secure it and lock it down, but it's a great attractive thing for hackers to get into. But if you're ultimately just recording your desired state of your cluster, then there's not so much in there. And you can use something like GitOps to have an operator within your cluster that reads from there and decides what to deploy. And finally, all this metadata you're storing along the way to show that you've got evidence of all these things, check that in a admission controller. This is your whole security story for delivering applications, and then Istio is the one that's finally going to protect you at runtime. We're not talking intrusion detection here. We're talking about policy between components and trusted workloads, things like that. OK, moving to Istio. This I have to skim through this for time. You can just kind of enable it in your cluster. It's not like a tick box, but you can install it and not necessarily start using its features. You will instantly benefit from the kind of telemetry that it offers, and then you can start to adopt it. I say a la carte here. There's a talk out there you can find on the internet, Istio a la carte, where they say that you can do this, and it's an approach they recommend for adopting it because they understand that there's a lot to get your head around. Maybe start with network policy then, and then start to look to canary releases. By doing this, you've also decoupled your build from your deployment, which is a good security thing. Anyway. OK, at the end here, I've got a bunch of links. Rather than having to photograph that, although you can, I've got a link for the slides on the next page.